Okay, welcome. This video is going to be describing how to write the equations of a parabola when it's given to us in standard form, or general form actually, and then we're going to write it into standard. So parabolas, writing equations in standard form. And our first example I'm actually going to steal off of this worksheet. So let's focus it. And I'm going to, it says for the equation of each parabola, find the coordinates of the vertex, the focus, and the equations of the directrix and the axis of symmetry, then graph the equation. So I'm going to just steal their example right there and paste it in here. And so here's our first example. So if I have this in general form, first of all, the reason we'd suspect that this is a parabola at all is because we have an x squared term with no y squared term. So it lacking a squared term is going to suggest that this, first of all, is a parabola. So it's a parabola since there's only one squared term. The other thing that I want to point out is because it's the x squared, back when we were used to graphing parabolas like this, y equals x squared, those were our vertically arranged functions, right, that were parabolas. They were vertically oriented. And similarly, when we're writing in from standard form or into standard form from general, if the x squared, if we have an x squared term and not a y squared term, then it must be a vertically oriented parabola. So it's vertically oriented, specifically because the x is squared. Alright, so that's just kind of some preliminary information that we're able to gather from this. Now, when we look at the form that I'm trying to write this into, the form for a vertically oriented parabola will be x minus h all squared equals 4p parentheses y minus k. So notice that the x binomial here is squared. I currently don't have an x binomial that's squared, and the only way I'm going to get that is if I complete the square. And everything else I'll be able to bring to the other side, because notice the y and our constants are all on the other side here. So that's the first thing we'll do. So I've got x squared minus 2x minus 8y plus 17 equals 0. And we'll start by adding 8y to both sides and subtracting 17 from both sides. And what we'll have is x squared minus 2x. I'm going to leave this foreshadowing blank line here, and I'll have 8y minus 17 and another blank over there. And this blank is here because we're going to be completing the square in just a minute. And when I complete the square, I find my new c term by taking b, dividing by 2, and squaring it. So in this case, this is going to be negative 2 divided by 2 all squared, which is negative 1 squared, which is 1. So I'm going to add 1 here and add 1 here. And now when I simplify, I can factor what's over here using a pattern. So I'll have x minus 1 all squared. And this minus 1, there's a couple places you can find it. It's half of our b value. It's also the same thing as the number we had right before we squared it when we were finding our new c term. And over here we'll have 8y, negative 17 plus 1 is negative 16. So now we're closer to what we want. I've got my x minus h all squared portion here, but y has to be in a set of parentheses up here, we see. and I have to factor out some constant. P here, just remember, is a number. It's a constant. It's not one of our variables like x or y. So what we'll have to do in order to get that is to factor out a common factor. Specifically, we have to factor out the value in front of the y, right? Because notice in this set of parentheses, there's a 1 in front of that y. So I don't want this 8 here, so I'm going to factor out an 8. And in this case, it's convenient that we have 8 and negative 16. Both of those are divisible by 8. But even if this 16 wasn't divisible by 8, I am taking out an 8 regardless, no matter what. Because it's possible that my k, or my vertex for my parabola, could be a decimal. So if I have to take out this 8 no matter what, and that's going to create a decimal here, we're actually okay with that. So let's keep going. So I'll have x minus 1 all squared equals, and I factor out the 8, I get 8 times y minus 2. And so now this finally looks like it's in that form, and I'm able to gather some information from this. So I'm able to notice that my vertex must be the point 1, 2, recalling that it's the opposite of these numbers, right? I can find out the value of p if 4p is equal to this number in front of the y parentheses, so 4p equals 8. I could solve that just by dividing both sides by 4. I get p equals 2. So notice, here's a little fact. If p is positive and it's vertically oriented, then this has just given us the information that the parabola opens upward. Right, so we're gathering these clues as we go along. So I can now find the focus. So it's a vertically oriented parabola, so I'm going to find that by adding the p to the y coordinate of the vertex. So notice that's what I'm doing. So this gives us 1, 4 as our vertex. Our directrix is an equation, so it's not a point. Since my graph is vertical, my directrix is actually horizontal here. And a horizontal line is given by the equation y equals some number. And what that number is going to be is our y coordinate of the vertex, and in this case minus p, which is 2. So that will give us the equation y equals 0. So there's our directrix. I can also find our axis of symmetry, which is a vertical line passing through the focus and the vertex. So that's going to be x equals a number. That'll just be the x coordinate of the focus or the vertex. So x equals 1. So now that I've gathered all of the information I need, at least I think I did, let's make a graph here. So if here's my grid, let's see, our vertex is at 1, 2, so I'm going to put some tick marks in here. Let's see, and 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So let's plot this point. Our vertex is at over 1, up 2. So there's our vertex. Our focus, we had determined earlier, was at 1, 4. So here's our focus. And our directrix actually is along the x-axis here. So far, the only point that's actually part of this graph is the green one here. That's our vertex. And then I've got the focus, directrix. So in order to find 2 other points so I can at least figure out what this parabola looks like, I'm going to use the definition of the parabola, which is it's the set of all points, or the locus of all points that are equidistant from our focus and directrix at the same time. So clearly this vertex is the midpoint between these two, right? These 2 segments would be equal. But I want 2 more points that also satisfy that condition. So what about the point that happens to be 2 of the p values away? So that's a total of 4. So if it's 4 away, it must be 4 away this way. Because notice that this is 4 units, this is 4 units. And it must be 4 away in this direction. So it must be right here, 4 units there, 4 units there. And now I can use those 2 points, and I notice that my parabola is actually a little bit wider. Maybe I can draw it this way, coming down, and that looks good enough. And there we go. And if I wanted, I could even throw in the axis of symmetry, as we said earlier, which passes between both the vertex and the focus. Right, so there's the directrix, and here's the axis of symmetry. All right, and let's actually check our answer. So going back to this, notice the vertex is at 1, 2, and it's a slightly wider parabola. Our directrix was y equals 0. Axis of symmetry is x equals 1. So it looks like we got it right, so good for us. And the key in writing it in standard form was just recognizing that whatever my squared term was, I had to complete the square for that, and then I end up taking out the kind of greatest common factor, pretty much the coefficient of our constant on the other side, in order to write it in that set of parentheses. So this was our standard form. So we're good. And so I'll see you guys in the next video.